application provides a real-time service of monitoring and control of a data center. The main actors of our project are the resource catalog, which works as a catalog for all the actors in the system. It provides information about endpoints of all the devices, resources and services in the platform. It also provides configuration settings for application and control strategies. Then the Raspberry Pi connector, which is an implementation of the device connector. It is equipped of 4 sensors: humidity, temperature, smoke and motion, to provide environmental information about the status of a room, and 2 actors, the AC and the dehumidifier. Then we have the message broker, which provides an asynchronous communication based on the publish-subscribe approach. Temperature and humidity control, they are control strategies that work as MQTT subscribe to receive information from sensor in the room, and also an MQTT publisher to send actual commands to switch on or off the AC and the dehumidifier in order to keep temperature and humidity in standard range. Then we have smoke and safety control, which are control strategies that monitor smoke detection and presence of someone in the room respectively. Each of them works as an MQTT subscribe to receive information of smoke sensor in the room and send an advice to the user through Telegram. In the end, we have some components that allows us to visualize and monitor the data, TeamSpeak and Freeboard. And then we have Telegram that allows us to manage the data. Hardware. The hardware is composed by a Raspberry Pi 3, a sensor related to temperature and humidity, a motion sensor, and 2 LEDs, which are simulating the AC and the dehumidifier.
Running the system. The system has been tested by curating a local network where each service has been run on different devices. Here we want to simulate a specific situation where the temperature and humidity are rising up. So we want to try to warm up the sensor and make the ambient more humid. The sensor detects new values. Each of them with their own topic publish new messages through MQTT to the Eclipse broker. These messages are eventually received by real-time data subscriber on the computer. On the computer side, we have a system that checks the data of subscriber by comparing the value with its threshold. If it finds the value is above that threshold, it tries to publish a message to the Raspberry to command turn on the corresponding device. If the value is below the threshold, the order will be turned off. The published order will be received by AC or dehumidifier subscriber on the Raspberry. Inside each subscriber, the order that just arrived is checked and the corresponding LED condition is updated. If the order is turned on, then the Raspberry, with the help of LED control configuration, turn the associated LED on. If it's turned off, it will turn the LED off.
In this project, in addition to the already explained part of temperature and humidity sensing, we have also some security features. In particular, a motion sensor and a smoke sensor. The motion sensor works by checking the external environment periodically, where the period is decided by us, and publishing data on the broker using MQTT. On the control side, the data are uploaded on the real-time data web service as all the other data, but, in addition, at this specific topic is subscribed a client that automatically sends an alert message on Telegram when motion status becomes 1. This means that the sensor has detected someone in the data center room. Just the same thing is done with the smoke sensor. The only difference is that we are simulating it using a random number generator in order to generate a, we can say, fake value that will be sent on the MQTT broker. Then, as for motion, if the smoke value is above a certain threshold, an alert message will be sent on Telegram.
In order to have full control on our system, we use the Telegram channel to get information about the rooms of the data center. Every time we select a specific room, we make a request and show data stored in real-time data. From Telegram channel, we are also able to modify thresholds by means of the specific feature which allows us to select a determined room and change every single value. Once this is done, we uploaded these new values on the resource catalog through a post. All data collected by our system are uploaded and stored on ThinkSpeak, an online database and data viewer. In order to do that, we create an adapter composed by two MQTT clients, one capable of getting data from the Eclipse broker, and one that publishes this data on ThinkSpeak. To allow an optimal view of real-time data, we use Freeboard, an online real-time dashboard that get the last data uploaded on ThinkSpeak and show them on an user-friendly screen.